I built this super compact bench power supply, one of the most important tools on any tinkerer or maker's desk. Here's how. Before I show you how I built my own, a quick explanation of what a bench power supply is. The ones you can buy look something like this, and they sit on top of your desk and they output power, but the key is you could very finitely adjust how much voltage, amperage it's outputting. For people who work on small electronics, whether you're building something new or taking apart and troubleshooting something old, you're dealing with so many different types of power. Arduinos take 3.3 volts, USB takes 5 volts, things take 12 volts, 9 volts, 23 volts, and you end up needing a whole bunch of power bricks like this, just to even test and troubleshoot any project you want. Now, I didn't want to dig through this box every time I worked on a project, and I also didn't want to buy one of these big, bulky, and expensive ones, so I set out to build my own. So I started off the project with this. This is called a buck boost converter, and it was about $25 from China. Now, this thing's actually gonna do most of the work for us. The way this works is you power it with a high power source, and then it's able to output using this dial and this screen pretty much any voltage and amperage you want. This is exactly what we need. The only problem is it only has one input and one output, so we kind of need to build everything else we need around it. So to power the whole thing, I'm gonna use this power brick I had on hand. It's 24 volts and 3 amps. This is plenty of power for what I need. So I'm gonna use this to power the converter, but now I have to figure out the ways that I'm gonna actually utilize the output voltage. I'm gonna keep things simple and have two types of ports I could plug things into for power. The first one being banana plugs, which are these really simple straight plugs that have one plug for positive and one for negative. Banana plugs are dope because they have all sorts of cables that you could have on the other end of them, whether it's these little clips that allow me to attach directly to wires, or these little plugs that let me plug into a breadboard, or even these alligator clips. There's just so many ways I'll be able to use these things to deliver power. I'm also gonna add a standard barrel jack because I have a lot of devices and chargers that already use these. And lastly, I'm gonna add USB and USB-C just because of how diverse they are. So now that I knew how I wanted this set up, I bought all the connectors I need. So here's how I'm gonna wire this all up. The main power source is gonna go directly to the converter so we can convert the voltage. We're then also gonna wire the USB ports directly to the main power. Again, because this was built for vehicles, it works perfectly off 24 volts. Now, here's another really interesting thing I did. My soldering iron is powered off 24 volts. And a lot of the times when I'm working on electronics projects, I'm using my soldering iron at the same time I want to be using variable voltage. So I actually wired another barrel jack directly to the 24 volt power from the power brick. This means that I could always plug my soldering iron in and use it while also having variable output from one of the other jacks. And lastly, the most important part, we have the female banana plug adapters, the positive and the negative, as well as a female barrel plug adapter. Both of these are going to wire to the output of the buck converter, so we're going to receive a variable voltage depending on what we have it set to. Now that we have all the components, I just need to design a case to fit around them. Started with just a flat panel, orientated all the parts around it, then 3D printed it out. Print turned out really well. I printed it with this raised inlaid text, so I could then print these other colored pieces so they'll slot right in. This makes it really easy to read how much voltage each port has. After all that, all the parts slotted right in. All of these are meant to be panel mounted, so they fit in perfectly. I was really happy with how this turned out. I was getting pretty excited at this point. Lastly, I wired it all up. The wiring is really simple on this, but I wanted to be extra thorough when I'm dealing with power like this. This is it all wired up. Now it's just a matter of plugging it in and hoping I didn't see a big puff of smoke. And after plugging in, it looks like everything's working. The screen booted up. It looks like the dial's properly adjusting the menus. Now I just got to print a case for this thing and we can test it out. So this is my workbench, and I want to have the converter kind of sitting in the corner here at an angle. So I took this piece of cardboard and I cut it out to be roughly the shape of what I think the footprint of the case will be. And after some tweaking, I got it right where I think I wanted it to be. I then took a picture of this piece of cardboard and uploaded it to my computer, and around it, I modeled this case, which has two pieces, this bottom piece and this lid with a little bit of ventilation. Printed them out. This took a while. These are pretty big parts. And this was the final product. I was really happy with how these things turned out. You'll see how it all fits together in just a second here. Notice that hole that's on the bottom where the charger pokes out. You'll see how that all integrates on my workbench here in a second. Now that we got it all together, look how perfectly this thing slots in its spot. This is so satisfying how well this thing fits in here. And because I put the power cable hole on the bottom here, it's able to slot right down the back of my workbench here and remain entirely hidden, and I am so happy with how this turned out. So I've got it all plugged in now and everything's looking great. Let's test this thing out and let me show you how it works. So for this first test, we have the trusty banana plugs plugged directly into a voltmeter. This is just going to read the voltage that this thing is outputting. What we're going to do here is turn it on. You'll see here we have it set to output 5 volts. When we push this button, we're getting a perfect 5 volts outputting out of it. This is really dope. And check this out, if I want to up the power, I could start turning this dial and I could change the voltage totally dynamically in real time here. You could change it down to like the 10th of a decimal place, but you'll see here as I turn the dial, I could dynamically adjust the voltage. You could also do it with the amperage. Maybe we want to see how much power it takes to light this LED. Right now we have it at 0.6 volts. I could slowly incrementally turn the voltage up until I figure out where the LED is going to start lighting. You see here right around that 1.8 volts, we start getting light from the LED, and we can turn it all the way up and just blow the whole thing out. And then while I'm working with my variable voltage, I can still plug my soldering iron directly into the 24 volts and start using that. Again, this is just going to be super convenient for the soldering iron alone. Lastly, of course, USB 3.0 quick charge, both USB-C and USB-A. I'm gonna end this there because that was a crazy long video, but thank you for sticking around with me while I nerd out. I am so happy with how this thing turned out. Not only is it gonna be a really useful tool, but I think it also looks really good, and the way it's set up configured is just so convenient, and I'm just so hyped on it. If you guys have any questions or criticisms of the like, please let me know in the comments down there. I'd be happy to chat about this thing more, but until then, I hope you guys have a great rest of your day, and I'll catch you in the next video.